All right. Well, we want to say welcome and good morning, good afternoon, good evening to everyone who is here participating with us today. This is the Ocean Plastic Filter Panel organized by the Solgaard Foundation. And today our goal is to have a panel discussion to unveil the Ocean Plastic Filter Project, which seeks to stop over 3 billion pounds of ocean-bound plastic annually. So I'm your moderator. I'm Danni Washington. I'm a television host as well as an environmentalist and ocean advocate. I host science shows for kids on national television, currently a correspondent on CBS Mission Unstoppable, which is about women in STEM, science, technology, engineering, and math. And I formerly hosted a show called Nature Knows Best, which focused on biomimicry and the wonderful innovations that we're creating around the world based on nature. So it's really, truly an honor and privilege to be here with you today amongst these three brilliant minds. Adrian has been a good friend of mine for a long time, and we've always kept tabs on each other and how we were moving in the world and what we were doing to protect our beautiful ocean. And so it's very exciting to share this space with him and as well as Tyler and Philip this morning. So thank you all so much. We want to make sure to kick off our discussion to get to know each other so that our audience will understand why you're involved in this project in the first place. And so I think the best way to kick off, there are lots of bios that I could read, but I'll just give a brief synopsis of each person. So Adrian, he's a sustainable entrepreneur and a thought leader and inventor, and he's the founder and CEO of sustainable goods travel goods company, Solgaard. And so really pleased that he was able to organize this morning. Philip Ehrhorn, he is the Chief Technology Officer at the Great Bubble Barrier, currently calling in from Germany. And Tyler Gearhart is the Director of Business Development for Clearwater Mills, LLC, which manufactures and operates stormwater trash interceptors. So we're going to have a great talk today. Let's kick off our discussion first by looking at the whiteboard video. This is a video explaining the basic concept of the ocean plastic filter.
So I'll just share my screen to show it. So we've taken the basic concepts, which is the bubble barrier, and that's what Philip's company does. They have air bubbles that run on the bottom of the river, so that directs plastic to the side and still allows fish to swim through. And then there's a collection wheel or conveyor belt system, which is what Tyler does. And if we put those two together and kind of have a really scaled up, massive version of the project, could look something like this. As the material then gets brought into the land, we can then collect it and upcycle it into something. So there's three main things. The high grade material, which is PET, that's bottles. We can use that to make fabric and that kind of thing. That'll probably be 5% of the material. A lot of the material will probably have some level of contamination. So that'll be going to the waste to energy plant, which is a CO2 friendly burning mechanism that will convert that into energy. And then some of the mid-grade stuff like HDPE, which comes from shampoo bottles, etc., that'll be converted into building bricks, and you can use that for making asphalt. That's kind of a high level of what like the concept is. What we kind of think it'll look like on a big scale is something like this. So that's just for the sake of giving a bit of a tease.
Great. Yeah, visuals always help. So that's wonderful. And now we can get into kind of the nitty gritty. But before we do that, let's hear from each panelist about why, in the first place, why is plastic important to you, this topic of plastic, and what's your personal connection?
Yeah, do you want to start with me?
Sure, Tyler, go ahead, kick it off for us.
Okay. So I'm Tyler Gearhart. I'm with Clearwater Mills. We manufacture the trash wheels and have gotten international attention for them. I got into the ocean plastics arena in a different path. I studied environmental studies in college, but I got a master's degree in historic preservation, and I worked in the historic preservation field for 20 years. And through that, of course, was very involved with urban revitalization and reuse of historic structures. And so I've always been into recycling. Through my work in historic preservation, I met John Kellett, who's the inventor of the trash wheel and the founder of Clearwater Mills. And we worked on restoring historic ships together. And through that, he invited me to join his small company. And so I got involved with Clearwater Mills, and obviously, ocean plastics is of course, a crisis situation. We have a lot of other news in the world now that's putting that to the side somewhat. But a serious environmental issue, obviously, and I think we have a great device, sustainable device for addressing that issue. And so that's how I got involved, and I'm glad to be working in this space.
Excellent. Thank you, Tyler. Philip.
Yeah, so my name is Philip. I'm one of the co-founders and CTO of the Great Bubble Barrier. And as Adrian mentioned, we use air bubble curtains to intercept plastic pollution in rivers and canals before it has the chance to enter our oceans. And for me, the ocean in general has always been the thing that motivates me, that has given me the drive to do what I've been doing my whole life, basically. I can't really even recall a moment that this started. I was a little kid. Free Willy was my favorite movie. And when you get a bit more, if you grow up and you start thinking, how can I use myself for the protection of the oceans? And I started studying naval architecture and ocean engineering to be able to be in a position where you could actually come up with solutions. So bringing an alternative to the table instead of being more of a passive bystander, just watching what's all going wrong. And that's the short rundown of how I came to the idea of the bubble barrier and later the team of the Great Bubble Barrier.
Awesome. Thank you so much, Philip. And Adrian, what is your connection to ocean plastic? For those who don't know already.
Yeah, so I grew up mostly in Vancouver, Canada, which is a coastal city. And then my mom was from Norway, and so we'd be in Norway sometimes in the summers, and we'd be sailing on my grandfather's small boat. And I realized this connection that it's like, okay, well, this ocean actually connects. And then we got a small sailboat in Canada that we kept in the US. And we were just a 45-minute drive into the United States. And I remember thinking, like, learning about how boats can pump out their waste and just thinking like, wait, if that's pumped out in the US, it still can come into Canadian waters. And there's no national border on the ocean. It's connected whether you're in Norway or Canada or the US or anywhere. And so by seeing the ocean as this one body that kind of connects everything, it just kind of became this passion point for me. Then I was in Bali a couple years ago surfing and thinking, wow, this is such a beautiful place, but there was just plastic in my face and in my hair. And I was like, got to do something about this. There's got to be a better way. So.
Absolutely. I think, we all know it's a pervasive problem and it is a crisis. As, Tyler mentioned, we have to deal with it, and we have to deal with it from a multi-pronged approach, looking at every possible solution. And that's why I feel most excited about this panel, because now we're talking about potential technologies that could really solve this issue. And so why don't we jump right into how each component, so the two contributions, the Great Bubble Barrier and Mr. Trash Wheel, and let's talk about their functionality separately, and then we can bring it together with the ocean plastic filter. So let's start again with Tyler. If you could just talk to us a little bit more of an in-depth overview of Mr. Trash Wheel. And I know we have a couple of images that we can show.
Oh, good. So as I mentioned, the trash wheel is invented by John Kellett. And John was a religion major in college, but he grew up on a farm in Pennsylvania. And so he was working on the Inner Harbor in Baltimore, running the Historic Ships program for the Waterfront Partnership, not for Living Classrooms Foundation. And, every day heard the tourists and other visitors to the Inner Harbor complain about the amount of trash in our harbor. So he got the idea or concept to, based on a hay thresher, to pick up the trash from the surface of the water, and using the water wheel that they used, obviously, to power grist mills and other historic mills that John knew growing up, and put those two technologies together to come up with the trash wheel. So the trash wheel sits on a floating barge, a boom spans the river, the boom funnels the floating trash and debris to the trash wheel. Great, thank you. There's some pictures.
We love the googly eyes. Everyone loves the googly eyes.
Googly eyes, yes. That's a credit to the Waterfront Partnership of Baltimore. So this illustration actually was done by the National Geographic magazine, and I think best illustrates how our machine works. So that has a raking system. When it rains hard, the rain carries the litter off the street, carries it down into the storm drains, and it comes out into the Jones Falls River. which is the main tributary flowing into Baltimore's harbor. The boom system, it's not a navigable river where we are. It's only about 120 feet wide. In the lower right-hand corner, it shows the watershed of the Jones Falls, which is about 50 square miles. And about half of it is in the city of Baltimore and half of it extends out into the surrounding counties. And so much of it is urban, but also there's a fair amount that's natural landscape and farms and so forth. So we get a whole mix of trash and debris during storm events, and a lot of organic material comes down with the plastics and glass and other things. So it comes to the front of the machine. We have a raking system that's powered by the water wheel and with the assist of solar energy as well. That drives the conveyor. The conveyor picks up the trash and debris, and then it goes up and falls into a dumpster, which is on a separate floating barge. And when the dumpster fills, we swap that out, push it shoreside. The dumpster is picked up by a dumpster truck and taken to Baltimore's waste energy plant. And that waste is burned to create electricity for the city. So in short, that's how our technology works. We've gotten inquiries and attention around the world, and I think we've had inquiries from about 100 countries total. But we still, and the first trash wheel, Mr. Trash Wheel, the one that's best known, we build and we operate the trash wheel system for the Waterfront Partnership of Baltimore, and they're the ones that get the credit for raising the money for us to install those and operate those, and they're also the ones that should get the credit for creating the social media, Mr. Trash Wheel, the googly eyes, and so forth, which has gotten us so much attention and really a cult following in Baltimore City. It's pretty interesting. So that said, with the first trash wheel was put in the water 5 years ago. We subsequently installed 2 other trash wheels on smaller tributaries in Baltimore City. So we have still just a total of 3 trash wheels in operation. They're all in Baltimore City. We're contracted to start a 4th trash wheel, also for Baltimore. And then we've just been awarded a grant as part of a project that's in Panama. So to be our first projects outside Baltimore and outside the country. And that's being funded by the Benioff Ocean Institute and is being locally sponsored by a group called the Green Tide, an environmental organization based in Panama.
Excellent. Thank you so much, Tyler. And just out of curiosity, I don't know if I missed this, but have you quantified how much in weight, how much plastic these 3 trash wheels have collected so far?
The weight of the plastics, not specifically. We know that Mr. Trash Wheel has been pulling out over 200 tons of trash and debris a year. And we actually sample the trash and debris. We know the number of cigarette butts. We know the number of plastic bags, plastic bottles, glass bottles, and so forth. So we know the overall weight, and we know the breakup of types of items, but we don't know the weight of those items specifically. But my guess would be, we do know that for Mr. Trash Wheel, the majority of trash and debris we pick up is organic debris. So falling limbs, leaves, mulch, people mulching their yards. We get a lot of that after storms. And the plastics is probably 20% of the total amount of trash and debris collected.
Got it. Okay. Well, let's pass it on over. Awesome. Thank you. Let's pass it over to Philip, who's going to give us an overview about the functionality of the Great Bubble Barrier.
Yes. I can actually also share my screen. Well, as previously already mentioned, so we use air bubble curtains basically to intercept plastic pollution in waterways. And we do that by placing a tube on the bottom of the river or canal. And that's a perforated tube with a lot of small holes. We pump air through that, and then the rising air bubbles will create an upward stream. which can bring plastic to the surface, and then once at the surface, together with the natural flow of the river, we can guide it to the side. And if you look at our bubble barrier in Amsterdam, you see that we place the bubble curtain in an angle. So basically, the plastic comes in, it's pushed upwards, pushed back, and then together with the natural flow, it starts being pushed to the side, and then will enter into our catchment system from where it's then emptied. One of the big benefits of the bubble barrier is that boats can still pass it without being hindered at all. And we also know that most fish species will just get through it and won't care too much about it. We initially started the project in 2 locations. So I was working on it in Berlin, while 3 young women were working on the exact same idea, basically, in the Netherlands. And at some point, when we started putting out the first images to more like family and friends, we coincidentally picked up on each other. When we got into contact and we found out we kind of have the same mission and vision about where we want to take the bubble barrier and what we want to do with it. So basically, once I handed in my thesis in Berlin, the next day I packed my bags and moved to the Netherlands. And together we are now the Great Bubble Barrier. We are a social enterprise. We started with a proof of concept, which I did in Berlin. That was just a bubble barrier of 10 meters, very basic, very improvised catchment system. We then got some funding from the Dutch National Water Authority to be testing it further. So we went into a water laboratory to see how we can optimize our system, how can we make it so that we use minimally energy while having the highest efficiency on plastic. And that we then applied to one of the biggest Dutch rivers called the IJssel. That was a pilot period of around 4 weeks, where we tested 180-meter long bubble barrier, where I was very nervous about. We kind of jumped from a 10-meter bubble barrier to an open water with commercial boat traffic. Felt like overnight. But we did see that the results from the small scale in Berlin scaled to the results we could see in the IJssel, and that was around 86% of the test material that we had used. And don't worry, we didn't throw in plastics ourselves. We used oranges and little wooden buoys that we had made ourselves, which were more affected by the wind, because we wanted to see what's the effect of the wind, what's the effect of the bubble barrier actually. And that was really the point that gave us the confidence to say, okay, we can do this. And then in 2018, we won the Postcode Lottery Green Challenge in the Netherlands. That was I think there were 840 applications from all over the world, and we won first prize, which was a bit of a shock. It was awarded with 500,000 euros, which was then really our starting point to prove what we can do. And we've started a pilot project to see if we also have an impact on non-visible microplastics. We've been doing that in a cooperation with a laboratory and a wastewater treatment plant in the Netherlands. We don't have the results yet. We expect that around the end of this year, the researchers have first right to publish their paper on it. But in the meantime, we've implemented the first permanent bubble barrier in Amsterdam, which you see here on Google Street View, which you can also find yourself. You can just go to our website and then to Amsterdam, and you find the link to Street View.
It's so cool.
Yeah,
It really is. It really is. I immediately think of myself scuba diving. When I see your technology, I'm like, yeah, I mean, that makes sense. And you look at a stream of scuba divers in the ocean and the bubbles are going up, like, of course, things are going to be pushed up. I always wondered, a lot of fish are very scared of the bubbles, but I'm assuming that the fish in the river have adapted and figured out, well, I can swim through this.
Yeah, we're also doing research on that. Especially juvenile fish might be more affected than adult fish. So it's something you always have to look at locally. It really depends on where you are. One difference to your scuba tank is it's not just one burst of bubbles and the fish go, whoa, what was that?
Yes.
Because we're like a constant stream. But with the ISIL project, there was actually someone who took underwater sound measurements, and he couldn't really hear the bubbles unless he was right next to the tube. What he did see was that we're actually shielding the sound of the passing boats.
Wow.
So behind the bubble barrier, it was actually, there was less noise. And that's one of the big applications that's also used in offshore technology when they ground offshore structures, especially in the North Sea. They're more and more obligated to use big bubble curtains. But then we're talking about tubes of this size, and they don't really care about energy or so yeah, that's a different level.
Is that for like whales and stuff? Because I guess whales are very sensitive to loud noises.
Exactly, that's the reason why they use that in the North Sea to have less noise pollution.
Cool.
Wow. So dual functionality. Excellent. Thank you, Philip. All right, Adrian, let's go ahead and move forward with the pitch. The ocean plastic filter, let's talk about that.
Yeah, so the idea really came from, Philip, you can stop sharing your screen.
Oh yeah, sorry.
So the idea really came from, a friend of mine, Cassia Patel, who works for Oceana Global, she actually introduced me to both of these technologies as we were talking about, like, we were sort of digging through, here's the data on ocean plastic, here's how much is coming out of rivers, and like, here's how bad the Yangtze is. And so, well, if that's so bad, why don't we just figure out a system for it? Then we started looking at the different technologies, and it's like, well, if we just take this and that and put them together and scale it up, there's probably an idea there. It's funny, Tyler, that you mentioned that John was working on a farm and he thought of a hay thresher. My second job ever was a raspberry picker first I was picking them, and secondly, I was on the raspberry picking machine, which shakes the trees. And then there's this massive, well, not massive, it's only like a couple feet wide, but this conveyor belt comes by and you just pick up the branches and you pick up the leaves and the slugs and you just let the berries go into their little containers and you're good to go. And so it's funny to think, like, these things that we get fed in our early life, these ideas just end up built, they're in there in your subconscious and they come out. But yeah, as I started sort of looking at this, it's like, well, why don't people are trying these very expensive solutions out in the middle of the ocean, but the facts are 90% of plastic sinks within 5 months of getting into the ocean. And so rather than trying to like perfect a solution on smaller rivers, let's try it on a massive scale first. And then even if it's only 50% efficient from the beginning, that's still gonna be stopping way more plastic than any other 100% solution would be. And so it's kind of taking this approach to life of like, okay, well, it's not going to be perfect, but it'll do for now, and let's go. It's kind of meant as this sort of duct tape solution. A little bit more in depth to what sort of how the system can look. I showed this image already, but it kind of shows a larger scale of these conveyor belts that come in, and some way to direct it. We're aware that there's going to be a lot of organic material, so we're thinking about using this standing piece over to the side where someone could potentially be standing there with like poles to push logs and branches and stuff out of the way to allow those to flow past. We spoke with a doctor who's done a lot of PhD, who's done a lot of research on the Yangtze River specifically, and we tried to get some understanding of just how much organic material there would be that's flowing through. And then we came to the understanding of how important it is to allow that to pass through out to the exit of the river, because this carbon-based life that comes from trees, branches, and all that ends up becoming fodder for different animals out in the sea. So it's good to know about that. So the general overview is that there's the bubble barrier would push the items towards these two large wheels, whether that's 2, 3, 4, there's some flexibility there. But thinking they would come into the sorting facility, then from there, it's a straight shot to the waste to energy plant. Again, because of the amount of the volume we're going to be collecting, having to drive that across the country by an hour or two by truck, we're talking about truckloads every single day. So it would just make sense to have it on site. Then we could have a PET recycling factory right there on site where the easier materials to upcycle could be done right then and there. And we could potentially even go as far as having a fabric mill there. So stuff's made and then it can get shipped out on a cargo ship directly from there. So we went through and did some initial renderings. And then here's kind of a bit of an overview. So we're thinking, we found this one site that's about 120 miles off the coast of outside of Shanghai, upstream. The tidal impact isn't too much because the river is so wide. It's 3 miles wide, or 4 and a bit kilometers wide. Or wait, no, sorry, 3 kilometers wide at this point. We could use a bubble curtain here to direct the plastic into this channel. And then from there, we'd use another set of bubble curtains to drive it towards the wheels specifically. The Yangtze River is an incredibly busy river with ships, so we need to kind of be cognizant of finding a way and a place that it could be protected. So there's still a lot of feasibility research that needs to be done on if that location is exactly the right spot and all that, but it's kind of getting this idea, and let's take the idea and run with it and see. Bring smarter and smarter people into the room and make sure that we're not missing anything, and then see from there what we need to do.
Absolutely. And I mean, being able to witness these renderings and at least have the concept out there, that's a huge step in the right direction. But as we know, with any new technology, there are challenges. So I'd love to hear from both Tyler and Philip in talking about how you are dealing with the current challenges and some insights when it comes to scaling up your technology to this magnitude.
I'll start. So yeah, it's a great, ambitious concept. So, and that's the way you obviously want to start thinking about the issue. And of course, a lot of people are thinking somewhat similarly. So not maybe on such a grand scale, but knowing that the Yangtze's, a major source of pollution, and how to tackle that on such a large scale. So the challenges from the trash wheel perspective is, of course, the size and scale of the river, much larger than water bodies we're currently in. The volume of trash and debris, as I mentioned, we're pulling out 200 tons plus, 200 to 250 tons a year from the Jones Falls. And Adrian, I think you estimated, what is it, 10 to 15,000 pounds per minute?
No, so we went a little bit further into it. It's probably closer to 6,000 pounds per minute. 6,000
pounds per minute. So of just plastics, correct?
Of just plastics.
Yeah. So the volume, is a major issue as well. You've addressed some of my concerns, fighting off a smaller part of the river, that side channel. That helps. And then the big obstacle, another obstacle with what you've designed, of course, I'm not exactly sure how you're powering the conveyors, but with the trash wheel, the conveyors are parallel to the flow of the water. So one issue you'll have is the fact that you're not parallel to that. So it will affect how that's done. So we would, one simple solution would be the concept of the conveyor at the water be parallel to the flow and then have some kind of turn, but of course that has issues related to it as well. And then overall, of course, just the scale and the cost and doing business in China are challenges that I've mentioned to you before. And then of course, our biggest challenge is just in getting the trash wheel done is everybody likes the trash wheel. Most people want to clean up the water. In Baltimore, we had the fact that the trash was so visible in our inner harbor, and that's the major tourist attraction in the center of the city, that the business leaders were like, when John came up with the invention, they were like, great, let's do it. So then, of course, we've gotten worldwide attention. We've gotten a lot of inquiries. Most places, it flows down the river, and then it's somebody else's problem, or it goes out into the ocean, and that's free. The cost of trash wheels is, it's substantial. They range between $500,000 and $1 million, per installation. The real challenge is once you capture the trash, you own it. And in Baltimore, we estimate it costs about $750 a ton for us to, for the removal of the trash from the water, pushing it shoreside, transporting it, and then disposing of it. So it's not cheap. And in Baltimore, they're willing to pay for it because it was so visible. But we really haven't found other municipalities that are willing to pay for that process. So
that's where I think it's really interesting, because you're in your situation, you're paying for the removal because you're paying the waste energy plant to take that Whereas
Correct.
in this solution, by having the waste to energy plant there, if we have someone who funds it, so one of my friends told me the idea of, what if you get Alibaba to sponsor this thing, and they have this waste to energy plant powering a local data center, then it's something that's creating energy for a high energy utilization item, and it can kind of then cover itself with the operating expenses through a system, something like that.
Right. Well, I think I applaud that. I mentioned to you we were involved with one of the Macarthur Foundation grants this past year for the $100 million change grants, and we were in partnership with actually the University of North Dakota, which strangely enough has an oceanographic institute. But anyway, they also have a professor there who has invented a new waste to energy technology, and I think it's called thermochemical energy converters. And part of the newness of that invention is they're actually transportable. They're like truck size machines. So the university took the lead on the grant application, and their proposal in part was to clean up the Ganges and to start on smaller tributaries that flow into that river for the challenges and reasons we've already discussed, and that one of our trash wheels would be sited on a tributary and then have a conveyor that went directly into one of these new waste to energy devices, and then create either fuel oil or electricity for the the local area. So they estimated that project with 6 trash wheels and 6 waste to energy converters would be about $100 million effort. So there is some thinking along that lines, and I think what you're talking about. Ideally, that's what we want to do. And of course, in Baltimore, the waste to energy plant actually creates a lot of toxic emissions, regrettably. So it's not the best solution, but some of these new technologies are much better in terms of cleaner emissions, and some even no emissions.
Yeah, and that's what we're looking at, and I think that's where China is actually leading the way with a lot of very clean waste energy plants. I think the one in Baltimore you have is 30 or 40 years old, so
it's older.
Pretty old technology. Yeah.
Yes.
So great. Yeah. Great. Well, in light of time, we have about 10 minutes left in total for this panel. So, Philip, we want to give you a brief moment to go ahead and explain your challenges when it comes to the Great Bubble Barrier, and then we can talk. We have one question that already came in. So for those of you watching right now, if you have a question, go ahead and type out your question in the Q&A box. You just have to click the little button at the bottom of your screen and contribute your question. So go ahead, Philip.
Yeah, I'll try to make it quick. I think one important point, Tyler has already mentioned it, plastic pollution doesn't really cost anyone anything, really, if you think about it. There's some calculations on the damage it might cost to ecosystems, but if you're brutally honest, not a lot of governments really care about that, because you can't translate that to economic cost unless it's efficient. And I think this is also the biggest challenge we have experienced as the Great Bubble Barrier. There's currently no policy on plastic in the water. It's not seen as a pollutant on paper, which means there's no obligations for any governments to do anything. However, we've seen that if we bring our solution to densely populated urban areas where we can pinpoint the source basically to a certain region and to a certain city, you can give the plastic an owner, and you can have a direct responsibility for the trash that's discharging into whatever ocean where you're at. And I think that might also be the challenge. Luckily, I wouldn't be tackling that. The whole permit side, I think, is on Adrian's plate, but really having a commitment from the government and being able to pull such a project on that scale will be a huge challenge. If we look more at the challenge for the bubble barrier, we know we can do a lot. We've only really tested until around 200 meters. We know that the tubing itself we can bring to even a kilometer. But of course, the question will be the energy versus the amount of trash you take out. You mentioned powering a data center, but you first have to deduct the energy you're going to use to operate the compressors to generate the compressed air. And one other thing for a river on such a scale is rivers are really, they're alive, and they move, they literally move. And especially also the sediment moves. So if you have such a large bubble barrier, because if you're on a smaller scale, for example, in Amsterdam, they dredge this canal every 10 to 15 years. We can just roll up the bubble barrier again, have the boats do the works, and then roll it back out. If we have a bubble barrier on that scale, and we do have dredge works, I'm not sure how we would realize that. And the other thing being, if you have sediment transport and you have high ship traffic, you do get boats that run on the ground. They don't necessarily get stuck, but a lot of times, and these kind of like coastal areas, they tend to touch the bottom from time to time, especially when the sediment is moving. So if we have one bubble barrier, even multiple ones, the risk of damaging one and then having to completely basically re-execute the implementation might bring a lot of costs with it.
Very valid points. Yes.
Yeah.
Yes. And it's interesting to me how like the producers of plastic should be the very first companies or entities that should be approached in paying for all of this, because it's ultimately their responsibility as producers of the material to see it in its end of life and to truly create a more circular economy that we can all live with. But I know that's probably in the distant future, but there's a great question here in the Q&A that just asked about the coronavirus pandemic era. There are a lot of people using surgical masks and other protective gear that are made of single-use plastics, and they're eventually being dumped into the ocean. I've seen it myself here in California on the beach, people just leaving their masks out. It doesn't make any sense. So Shubham is asking, can you discuss the probable measures to be taken about this specifically? And I brought that point up because, yes, we are in an era where we have to rethink everything that we do. And so, your thoughts on that question?
Yeah, I mean, we've also seen that. We've seen having masks and gloves popping up in our catchment system in Amsterdam. Really, I think the key point is education. You really don't need gloves. I mean, at the end of the day, if you have gloves on, you touch a surface and then you still touch your face, then you have a problem, right? And if you just use soap and wash your hands for 20 seconds, you're just as good without wearing any gloves. And I mean, we've seen, I think every fashion brand has brought out reusable face masks. And I think studies are coming out that show that these are less effective, but maybe even still effective enough. And they can be just washed at home and reused multiple times.
I think the pandemic has unfortunately reinforced our dependence on plastics generally. I mean, what we're talking about, medical waste, is just a small portion of that, and is also the effect on the economy. I mean, part of this issue is, it's an environmental issue, as we discussed. The cost of it, it's free to let it flow down the river. So I think
it's free now. It's not free in 10 or 20 or 30 years.
Yeah, free. I don't mean to say, I think there's a huge environmental and fiscal cost to it, but that's not what people are thinking about, as opposed to just the cost of removing it. So I know from our experience, our projects have stalled. Everything's moving more slowly because of the pandemic. And I think we're going to be dealing with the fact that we know foundation support and other things have been focused on other issues. And so some of that funding that might have been available for addressing ocean plastics has been focused on other priorities, seen as other priority needs now in the wake of the pandemic.
I think that's sort of what Danny brought up with like some of these large companies that are producing a ton of plastic, like let's say Coca-Cola, for example. For them to work together with a solution like this, it's just them writing a check from their corporate social responsibility department to help make something like this happen. And I think that something like that could be a really good way to do it. But I think that kind of brings in like that challenge, and that sort of really interesting bit about this project is getting the cooperation of corporations, but also like the governmental support within China. This is such a huge opportunity for China to be a leader in the world and to do something that's going to help all of the world. And seeing the rapid approach that China took to dealing with the coronavirus in Wuhan, in the way that they built 6 hospitals that could house 1,000 people each, and they built those in 6 days. And that's kind of where like my ambition for this project is, if we can approach it with that kind of urgency, that we could have this thing up and running in a year or so. And it maybe not at 100% efficiency at first, but if we can get it running, if we can just kind of cut through the red tape to do that and, start there, that'll be, a couple billion pounds of plastic less in the ocean next year. And we need to start thinking, I think, urgently about these kinds of things.
Absolutely. Absolutely. So we've got a couple minutes left. We have 2 more great questions. The first question is directed toward Philip. Our attendee asked, how did you choose where in Amsterdam to implement the bubble barrier?
Yeah, so the city has basically 5 outlets where the water leaves the city and then goes into a canal that ultimately leaves a couple hundred meters downstream into the North Sea. And the ambition of the city was to have basically a 0 negative impact on the North Sea in the future. This is now the canal that is discharging most of the water from the city. So for the city, it is a pilot, just for them to see how it works within their existing infrastructure, which is always, of course, also a challenge. And then if everything is running according to plan, which it currently is, we're collecting more than expected, we'll be looking at 4 to 5 additional bubble barriers in the coming 2 to 3 years. Only in Amsterdam.
Oh, wow. Yeah, totally ahead of the curve. I love it. So the final question, and whoever wants to answer this, feel free to do so. The main focus of this course, this question is from Ellis, by the way. She says the main focus is, of course, it's the cleaning of our waterways. However, we cannot forget about other factors affecting our environment, such as emissions. How long would it take for any such facility to become net carbon 0?
I think that really comes to the waste to energy plant. And as long as that's done in a very carbon efficient way, with carbon scrubbers and everything in the latest technology, I don't think that would put out a ton of carbon. And then as far as the collection process itself, that wouldn't be generating carbon, because it would be, if it's using a system similar to the water wheel that powers Mr. Trash Wheel, I think it from the start, it should be pretty low carbon emissions.
Of course, I mean, there's always the option to be looking into renewable energy to be powering this. I think China at the moment is the biggest investor in renewable energies, I think more than the whole of Europe and combined. And there's still one big question also about plastics entering our oceans. There was a study that came up from the Hawaiian Sustainable Coastline. I'm not sure what their name was.
What Sustainable Coastlines Hawaii.
Yeah, exactly.
Yeah. We designed a project for them.
Oh, great. So one of the researchers associated with them, she found that the plastics actually, when they're degrading, they're actually releasing greenhouse gases. We don't fully understand yet on what scale that is, so how much that is, and how much it affects over the effect over time. But it's certainly an effect we shouldn't neglect, and especially the costs we had put into to produce the plastic pollution. That's where it comes down to. We don't have the actual cost for it. We pump air out of the earth. No one is paying for the spills that are going on, and they're going on constantly. And no one is really held accountable for it. Then we start producing the plastics, and as soon as they leave the factory, no one is really responsible anymore. And then, as again, as Tyler said, it's free to dump them in the ocean. I think we really have to start looking at the whole overall costs of our plastic consumption to put into relation what kind of efforts are actually, useful to prevent plastic reaching our oceans.
Right, exactly. Well, thank you, gentlemen, for all of your brilliance and insight into this. Of course, this is just the beginning. This is when we're presenting an idea, it's going to take time, but there are ways that those who are watching today can support. And we'd love to encourage you to head over to change.org, where the Solgaard Foundation has launched, and Team Planet have launched a petition for you to sign to help support the ocean plastic filter and its implementation. So make sure to head over to the link. I added it to the chat, so you can just quickly hit that hyperlink. I see that we have a couple of questions in there, but thanks, Adrian, for answering LJ's question. So any closing thoughts before we go? Just brief action steps that we want to tell our audience.
Well, I have one thing I'd like to mention about the trash wheel and the googly eyes and the sort of cuteness of it all and the social media success. It's raised awareness about plastics and plastic pollutions, and it's changed behaviors in Baltimore. And it's also led to the ban of plastic bags and styrofoams in the city. So there's some great education and outreach opportunity and benefit there as well.
Yeah.
Fantastic.
Yeah, and I think that's where like we're trying to go the route of awareness first on this, because the more, if there's awareness around this one river, it'll kind of make everyone more aware of their relationship with plastic, how they're using it, and everything like that. So I know this is a project that's got a lot of complications ahead. It's got some pretty massive challenges, but if it was easy, it would have already been done. And I think anything worth doing is going to be hard. So
yeah, I think every individual can contribute to the greater goal of all of these. While these projects are absolutely needed, don't only put your trust that someone else will, clean up your mess. Start taking responsibility for where you can take responsibility. No one has to, carry the whole burden of all the disasters that are currently going on. Small things do matter, and they take time, but, we have to start, and that's what this is as well. You have to start at some point, and then it will develop over time.
Eloquently said, Philip. Yes, absolutely. There's 7-something billion of us on this planet. If we all just did something, it started somewhere, we can definitely do something. But thank you again to Adrian, Tyler, and Philip for making time and to be here. And thank you to everyone who joined us as an attendee. You could have been doing a million other things, but you chose to be here with us. So thank you very much. We appreciate it. And please stay tuned. Follow the track of the Ocean Plastic Filter, because it's an exciting one. I think something great is going to happen here. So thank you.
There's more info on teamplanet.co, and then we'll kind of keep it going from there. But yeah.
Awesome. All right. Well, everyone have a great rest of your day.
Thank you.
Thanks, everybody.